Alright, hell yeah. So we have linear algebra, and I've been studying this book. And we've been about 3 hours a day going to the coffee shop, hell yeah. And we're basically about like here into it. We're almost done. So that's pretty sweet. It's been one of the first subjects I've kind of stuck with, start to finish in a long time since actually going to college. Hell yeah. Okay, but what we're going to do today is the inverse matrix. This is going to be part 2. Part 1 is that we solved it in the way they wanted to solve it. You know what I mean? Just kind of using, different... Anyway, so hell yeah. Today we are going to kind of do it more intuitively. And we want these values. So we want a matrix where we have this value, all these, there's 9 values that we need. And then multiplied by the scalar. So this value is actually negative 7 divided by 112. So keep that in mind. And an inverse means that if I do have this matrix A and I multiply it by the inverse matrix, I get the identity matrix. Hell yeah. And so this can be a check on reality. It also can help us figure out, because I want to solve this using just 9 equations, 9 unknowns. The other thing with this one is I can do the inverse matrix times A. So this order doesn't matter, still comes out the same. Cool. So if, what I'm going to do, I'm going to do this form. So I'm going to say, hey, I have a matrix that's A, B, C. This is going to be the inverse. A, B, C, D, E, F, G, A, B, C, D, E, F, G, H, I. Hell yeah. And then I'm going to multiply it by this matrix. 1, negative 1, 5, 3, 9, 7, negative 2, 1, 0. And then what I want to get, if I do this, I'm going to get the identity matrix. And so that's what we're going to have. Okay, so now let's start chiseling away at the equations. Bummed that I drew this so small. But anyway, this row gets this row and this row. So if I'm sorry. No. These two are being multiplied. So it's the row of this matrix multiplied by the column of this matrix. So we have 1A plus 3B minus 2C is equal to this value right there, 1. So that's going to be the first equation. So we have 1A plus 3B minus 2C is equal to 1. Hell yeah. And then we just go to the next value. So if I want this value, is 0. And I'm going to do this row and this column. So I'm going to have negative A plus 9B plus C. So I'm going to do negative A. And I honestly don't want to do that. Instead of going that way, filling in, let's go down. So let's solve for this one. So we're going to solve for this value, we're going to take this row and this column. So we have 1D, 3E, negative 2F. So 1D plus 3E minus 2F. Hopefully I did that right. So this row, this column, 1D plus 3E minus 2F, that's going to be that value. The next value is 0, and then so we're going to have this row, this first column, 1G, 3H minus 2I. So 1G plus 3H minus 2I. And we just do it on repeat. What I'm going to do now is, should we do all 9 of them? Might as well. No reason to get to there and stop, because if I want this value, so it's right there. It's first row, second column. So we have negative A. So it's going to be negative 1A plus 9B plus 1C. And then this value is equal to 1. It's going to be the second row, second column. So we have negative D plus 9E plus 1F. And you can see that these values, this is 1, 1, 9, 9, 1, 1. So the next one should be -1 something plus 9 something plus 1 something. And which one are we on? We are right here. Wait, no, second row, right there. We're at the last one. So hell yeah, this row, second column, -G, -1G, 9H, and then 1I. Cool. All right, the next three equations are over here. So this row, this third column. So we have 5A plus 7B plus 0C. Cool, I'll still put that in there. Is equal to 0. This next one is 0, next one is 1. And then we have, so this value is this row, this column, 5D plus 7E plus 0F. Alright, so this value is 1, and we're doing this row, this column. So we have 5G plus 7H plus 0I. Okay, hell yeah. So right now we have 9 equations. There's 3, and there's 3. And we have 9 unknowns. We just don't know what A, B, C, D, E, F, G, H, I is. And then so what we're going to do is we're going to set this up using Gaussian elimination. And so what we're going to do, I'm just going to do this. I'm going to say like A, B, C, D, E, F, G, H, and then we have I. And then we need 9 equations. So the first equation is 1A plus 3B minus 2C is equal to 1. Well, you got to know that this is also plus 0D plus 0E plus 0F plus 0H plus 0I. 1, 2, 3, 4, 5. Why am I missing letters? You know what I mean? I don't do the alphabet very much. A, B, C, D, E, F, G plus 0G. Cool. Hell yeah. The alphabet would be way cooler if it had more G's. Alright, so we got 1, yeah, so this equation is just going to be 1 there. We got 1A, 3B, -2C, and then all the other ones are 0. So this is how we can represent this. And what we're doing is we're saying that, I don't even know how to actually write this. Yeah, what are we saying? Well, maybe I'll come to that. Like the technicality stuff, I'm kind of bad at. But this makes sense to me so far. And that equation was going to be equal to 1. So there you go. And in essence, we have an augmented matrix. We're saying that, what are we saying? Oh, yeah. No. Because these can be in any order, it almost be, I can't get into technical. Some parts, yeah, I'm just learning this stuff, and so, like, yeah, like, so the form is like AX is equal to B, and if this is the vector I don't know, it could be X, Y, Z, you know, vector. This is the matrix, and this is the solution matrix. What could I say? I can set this up as an augmented matrix where I have this and my solution set, and that's what we're doing. And then when I get this matrix as like a 1, you know, something, and then a number, and then 0, 1, something, and then a number, 0, 0, 1, and then a number. I know that, and this is X, Y, Z, I know that my Z value is this number. I know that my Y value is this number minus this times Z, you know what I mean? And then I know my X value is this number minus this number times Z minus that number times Y. So that's the order that we're going to be doing it in. Hell yeah. So that's the first equation. Second equation, that's why I'm just going to go to this one. It's going to be, whoa. Yeah, no, right there. Because we have, Oh, this is interesting. Yeah, I don't think... Yeah, no. Oh, so yeah, so maybe this isn't the way that I wanted to do it. Yeah, because that's the trouble that I got into last time. The first time I did this, I actually set it up this way, where the next line I just went right to 1D, 3E, negative 2F. But today I did it differently, and it worked so well. So we're going to do that. So the next value has to have a 1. No, the next value is going to be my A term, B term, and C term. So hell yeah. So this next one right here is negative 1, 9, and then 1, and that's all equal to 0. So all those all the way out. So I'm just, yeah, and then the next one is going to be this A term is going to be 5, 7, and 0. 0's all the way out, and this is equal to 0. Hell yeah. And then I'm going to do the DEF terms. So that's going to be 1, 3, negative 2, and that's going to be equal to 0. We have a negative 1, 9, 1, so we have a negative 1, 9, 1, and that's equal to 1. And then the DEF, we have a 5, 7, 0 is equal to 0. Now we're going to move on to the GHI terms. So the GHI terms are right here. And I'm going to have, where's the first one? We have 1, 3, negative 2. So 1, 3, negative 2, that's going to be equal to 0. We have negative 1, 9, 1, the GHI, and then we have a GHI term, 5, 7, 0, and that's equal to 1. All right, and then we can kind of, alright, hell yeah, I just recopied this, and so we can have this as a reference. So, yeah, this row is going to be multiplied by this column, and this column. So I should have a 1, 3, negative 2, a negative 1, 9, 1, and then a 5, 7, 0. And that's what I have. 1, 3, negative 2, negative 1, 9, 1, and then a 5, 7, 0. Second row, I'm going to have that actually the same pattern all over again. 1, 3, negative 2. And so these should be all the same. So I'm just going to do a little double check. And hell yeah, now we're just crisp. And then it was so fascinating because I'm glad I stumbled across this. Because if it's set up like this, these values are all 0. You know what I mean? We can write them in. And then so these values finishing the deal. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Cool. Gets a little cluttered. Probably shouldn't have done that. But now what we need, just to do the Gaussian elimination, is just to, like even just down here, if there was a value here, if I got a 1 here and then a number here, I know what that value is. And if I get these to be 0, hell yeah. And then if I know this value, I can throw that value into there. So all I would need to do is get rid of that term. So then we would know what we need to do. So that's essentially what we're going to do. And the fascinating thing about this is I just make so many errors. So it's just really interesting. And the other interesting thing about this is because there is no values from here down and here down, I can either start here and find these 3 values, or sky's the limit. I could start here. I could use my elimination to get a value right here. Because these rows are 0, nothing's going to change. If I add these rows together, 0 plus 0 is 0. If I multiply this row by 2, 0 times 2 is 0. And so when I add these rows together, these values don't change. Okay, hell yeah. So let's maybe start down here. I guess we can start anywhere. So what we want to do is just get rid of, we want to turn these 2 rows into zeros. We can either add or multiply rows. So here, we're already set up to add these 2 rows together. 1 plus a negative 1 is 0. 3 plus 9 is 12. Negative 2 plus 1 is negative 1. 0 plus 0 is 0. So very simple, but each of those I could have made a mental error on. Okay, the next one, I can't just do 1 plus 5. 1 plus 5 is 6, so I got to boost this one up by 5. And can you do this in your head? Like if you can't do it in your head, you would go 5, 15, negative 10, and 0 times 5 is 0. And then I could now I could subtract. If you're not good at subtraction, do this. Negative 5. Well, just do negative 5, negative 15, positive 10. And the 0 doesn't change sign. And then you can add them. But let's try to do this mentally. So I know I'm going to increase this by 5. I'm going to say 5 minus 5 is 0. This is going to be 15 minus 7 is 8. This is going to be negative 10 minus 0 is negative 10. 0 minus 1 is going to be negative 1. Huge place for errors right there. Because if I do have, yeah, because the way I chose to do it was I chose to do this positive, positive, negative 10 and 0. And then if I'm subtracting, 5 subtract 5 is 0, 15 subtract 7 is 8, negative 10 subtract 0 is negative 10. 0 subtract 1. 0 subtract 1 is negative 1, and that one gets me a lot. I might miss that sign. Okay, so now we got those to be zeros. Now we need to get these to be zeros. Or, we just need to get that one to be a 0. So what I'm going to do is get this one to be a 1. I'm going to divide by 12. So 12 divided by 12 is 1. And then I'm going to say this is negative, so I'm just going to cross that out for a 1. And then this is negative 1/12. 0 divided by 12. Sometimes it is useful to do that. We'll see. Just to know that, hey, don't forget about that term. Because now we're going to have to add or subtract these. And I need to boost this one up. And I'm trying to do this more in my head. Because again, I would come in here and multiply this by 8. And then I would have negative 8/12. And then I would have 0, still 0/12. And then I would subtract. 8 minus 8 is 0. Negative 8/12 minus 10. See, that's difficult. But negative 8/12 minus... see, I just made the error. See, this is negative 8/12 minus a negative 10. So it's going to be minus a negative 10, which is a negative 120 twelfths. Negative 120 twelfths is negative 10. So these two negatives become a positive. Now I have a positive 120 take away 8 is going to be, this is positive. So I'm going to have a positive 112. And even right now, it's like my brain is fried. It feels like I made a mistake. But hell yeah. So right there, we're going to have, this becomes, and it's positive 112 divided by 12. So this is 112 divided by 12. And I didn't make a mistake. I think we're good. But I almost made a mistake by not putting the denominator. Hell yeah. And now we have our we need to get this by 1. I need to multiply by a 12 divided by 112. So that's what I'm going to do over here. I'm going to do 12 divided by 112. And that's going to be negative 12 divided by 112. And then I finally have a 1 right there. And then I have this right there. And let's see if we have a check. And no, we're off by a sign. That's such a bummer, man. And so, first mistake, but that's the reason why I'm doing this, because it's almost impossible to do it without mistakes. So, so hell yeah. So let's give it a go. Yeah, let's find our error first. So, what do we have right here? This was 12, and now we got it down to 1. This is negative 1/12. This is still 0. It's this part. I totally forgot. So I just did that. This is the mistake I've been making today. I'm trying to subtract this equation from that equation, and because this is 0, I forget to subtract 0 from this. So 0, subtract, and this is still, what is this? Still negative 1. So I have 0, subtract negative 1, which becomes positive 1. So now I'm left with positive 1, and is equal to 112 divided by 12 on this side. And then I multiply by that factor of 12 and this becomes a positive 12 divided by 112. And that's this value. This value right here is 12 divided by 112. And 9 equations, 9 unknowns, we got 1. Hell yeah. And we really need to blow this up for the video. I totally apologize for not having, you know what I mean. So let's do this. Just so you can kind of see this process just a little bit bigger. Because this is getting a little bit small. And we're not even done. So currently we still have 1, 3, negative 2, augmented 0. This got down to 1, 0, negative 1/12, 0. And then we finally found our value here at 12, 112. And so this is going to be the I term, this is our H term, and then our G term. So our I term is this, and so that's that, A, B, C, D, E. I can't do the alphabet, but that's the I term. Hell yeah. So, and then our H term, which is right here, is going to be, well, it's going to be, so this is saying H minus, so this equation says H, 1H, like 1H, minus 1/12 I is equal to 0. I know what I is, so we're just going to get H by itself. So H is equal to negative 1/12 I, which is negative 1/12, and I is 12 divided by negative 1/12. So this is going to be negative 1 divided by 112. And that's crazy. There's another sign change error, and it's because, I'm glad I'm doing this, because these are all the same mistakes that I've just made almost 1,000 times now. And I think we're good right here with this. Alright, hell yeah, sorry about that. The camera cut out, but I found my mistake. I just got to here with the verbiage, so booyah. So this equation is H minus 1/12 I. To get this to the other side, that negative goes away. You know what I mean? Yeah, and maybe it is good to start using, I'm going to add 1/12 I to both sides. Those cancel. I don't know. But anyway, so that was the negative mistake. So now I have H is equal to 1/12 I. I is 12 divided by 112. The 12s cancel, and I'm left with H is 1 divided by 112. And that factors to be, well, that's 1 divided by 112 times 1. And that's what we're doing here. 1 times 1 divided by 112, or 1 divided by 112 is that value. So that's what we have for that value, and that checks out. Alright, now we have our value for H. H is equal to 1 divided by 112. And then 12 divided by 112 was going to be I. And now we're going to find G. So, get a little more sheet of paper. So we have, and you can make this matrix go smaller. I think for me, my taste is just get to here and then go for it. Yeah, I think this is a very useful matrix form. I think it's called reduced. It's reduced row echelon form. This is not, but it's just row echelon form. So we do have echelon, and this doesn't even have to be 1. One of the videos, Prime Newton's, that was a really cool video to watch. Be like, hey, this could be 2. It's still row echelon form. It's just not reduced. So hell yeah, I like that. But anyway, so we get down to here, so I can just say, so I'm just trying to do this real fast. G is equal to, get that to the other side, 2I minus 3H. And then we're going to be 2I is that 12 112ths, so that's going to be 24 112ths. H is going to be 1, so we have minus 3, because this is going to be minus 3, 112 is minus 3, 112. Denominators are the same. 24 minus 3 is 21. And so we have this. So our value for G is going to be 1 divided by 112th multiplied by 21. 21 is the value that's going to be right there. Hell yeah. Okay, sweet. So that was the process to get the 3. And the interesting thing about this is it's going to be the same process to get these ones. But why is the number going to be different? Like, why aren't these numbers just all the same? We just solved for these. Well, it's because this was 0, 0, 1. This is 0, 1, 0. And I think it is useful to kind of just grab little sheets of paper. Well, now let's stick to it. Even though this is very small, a lot of this stuff is just we want to do it mentally. You know what I mean? And my brother was just like, well, you're probably making mistakes because you don't have enough space. But still, they're still like using what you got and then still trying to stay organized. And I think it's useful because if I do make a mistake, I can identify where I'm making a mistake and try to, I don't know, try to be more aware of that. Alright, so I need these to be 0. We're going to start with this one. If I added these two rows, this would go to 0. 1 plus negative 1. So I'm just going to add these, 12, negative 1, 0. These add to 1. Alright, so we're kind of doing that same process. This is the same process. Boost this up by 5, this goes to 0. 15 minus, yeah. So if I boost this row up to 5, I have to subtract this row. So I'm going to 5 minus 5. 15 minus 7 is 8. Negative 10. And then I'm going to have 0, because this is 5 times 0 is still 0. 0 minus 1 is negative 1. Hell yeah. Well, I'm sorry. This was the one from that upper row. We're doing this one. So, yeah, 5 minus 5 is 0. 15 minus 7 is 8. Negative 10 minus 0 is negative 10. 0 minus 0 is still 0. Cool. This was a 1, though. No, was this 1 or negative 1? Now I forget. No, we were adding them, so this is a 1. Okay, we got 2 zeros there. We need to get this to be a 0. I'm going to divide this row by 12. So I'm just going to say this goes to 1, divide by 12, divide by 12. Now I'm going to kick this row up to 8 and then subtract these two. In the beginning, what I had to do was kick this row up by 8 and then change the sign. Make this negative 8, positive 8 twelfths, and then negative 8 twelfths, and then add them. I really couldn't subtract, but I'm getting better at subtracting mentally. So if this goes to 8 and subtract, we're going to get 0. This goes to negative 8. So this is going to be negative 8 twelfths. Subtract. So it's going to be subtract a negative 10. So it's going to be adding. And this is going to be 120 divided by 12. That's 10. You know what I mean? Or, subtract a negative 10. That's kind of the operation that we just did. And then this is going to be positive 1/12 twelfths. So this value is going to be positive 1/12 twelfths. And then when we get this, I always forget about this one. This is still 8 twelfths. Yeah, that's the one we're doing, right? Yeah, these two rows. This is still 8 twelfths minus 0. So this is just 8 twelfths. Okay, and now just multiply by the inverse. 12 112ths. 12 112ths. 12s cancel, and I'm left with 8 112ths. So we found our next value. So this value f is 8. And then hell yeah. And then since we know that, we're gonna do this one. So now this E is 1/12, but then I need to multiply this by that. It's going to be a negative, and then subtract it, or move it over to the, add it to the other side. So yeah, and that's where I make a lot of mistakes. This is negative 1/12 multiplied by f is a positive number. And then I'm going to move it to the other side, which is adding it to the other side. So I'm going to have 1/12 over here plus, And this is a huge mistake as well. So look at this. This is where just doing things mentally is just like, I see a 12 and then I see a negative 1/12. So this is 1/12, sure. So let's write this full equation out. So this is 1e minus 1/12 f is equal to 1/12. Let's solve for e. So e is going to be 1/12 plus 1/12 f. But check this out. 1/12 plus 1/12, what's f? F is 8 divided by 112. Look at the denominator. Denominator blows up, so I need to come over here and multiply top and bottom by 112. So now I have 112 plus 8, which is 120, divided by... And this still doesn't give us our answer, because this is 120 divided by a denominator of 12 times 112. So this is where I'm getting better at factoring. You know what I mean? Because this is 12 times 10, 12 times 112. The 12s cancel, and this value is 10 divided by 112. So that's where we get 10 divided by 112, and that is E. Cool. So now we're going to move on to D. So D is going to be 0. We're going to have 2 times F. So I should circle these, but we can just use this. This is A, B, C, D, E, F. So we're going to have, so D is going to be, I'm going to add it to the other side. So it's going to be 2 times F, which is 8 112s, minus 3 times E, which is 10 112s. And that's it. So I'm going to have 16 minus 30. I have a hard time with this. I'm going to use the number line method. 16 minus 30, I know it's negative. I'm going to say 16 and 30 are on a number line. I'm going to increase the lower one by 4, and so that goes to 20. Increase this one by 4 goes to 34. The difference between them now is an easy jump is 14. For whatever reason, that, I don't know. And then, come back to be like, well, 14 plus 16 is 30. Do it in the reverse order. But subtraction is a mental killer for me. Just from an intuition perspective. Alright, hell yeah. So what did we just do? Yeah, we got 14. I think we lost track of reality. But yeah, we got 14 divided by 112. And I forgot about the negative. So doing this number line method, I'm always saying, hey, it's going to be negative. And then just set the numbers up, figure out the difference, and then make sure to put that negative back, which I just didn't do. So it's probably a horrible method. So yeah, we got negative 14 divided by 112, and that's that value. Alright, we almost got no more battery juice left, but let's see if we can kick this out. So we're down to the last one. We're going to do that same process. You know what I mean? This goes add 0, 12, negative 1, adding goes to 1. I'm going to boost this up to 5, multiply this equation by 5 and subtract, so we got 0. 15 minus 7 is 8, negative 10. And then we're going to have 5. I need to boost this up. 5 minus 0. This is 5, so that definitely changes things. Alright. Yeah, is that what I want to do? Yeah, and then, so that was that equation. Cool. Now I need to get rid of one of these zeros. I'm going to divide by 12. That becomes 1, divide by 12, divide by 12. Boost by 8, and then subtract. So this becomes 0. This is your negative 8 12s. Subtract negative 10, which is adding 120 12ths. So that's that 112 12ths. So that stays the same. It's just kind of interesting doing the same thing over again, and it feels no easier than the first go around. Okay, and then here, don't make the mistake, because I'm boosting this one up by 8. So I'm going to have 8 12ths minus 5, which is 60 12ths. 60 twelfths. So I'm going to have 52 twelfths, negative 52 twelfths. So hell yeah. So when we do this, this one becomes negative 52 twelfths. I could have made an error, but it's ringing a bell from before. Okay, and then what's the answer here? So now we did that. Which one did we even do? Yeah, we boosted that. We wanted to get this to be 0. We got that to be 0. I want this to be 1 multiplied by 12 divided by 112. So over here, 12 divided by 112. And then we see that that value C is going to be negative 52. And that's what we have right there. So we got our value for C. I'm going to go to this equation. Sorry it's small, but this is where it's useful. Now, making it hella small wasn't, I mean, it's not even useful for you. And it's really difficult for me. So, my apologies. But it's still useful. I mean, I can tell you the numbers. I have a 1 here, negative 1/12 there. And then over here is a 1/12. So I'm going to take 1. This is where we're going to run into that issue again. 1/12. I'm going to add this over there. So it's plus 1/12, but multiplied by C, which was negative 52 112. So now this becomes negative 52 12 120. I got to multiply this by 112 top and bottom. And now I have 112 minus 52. Again, hate it. It's going to be a positive. I have 52, 112. I'm going to boost this up by 8, go to 60. Boost this up to 8, it goes to 120. And now I can easily see there's a difference of 60. So the number line method works pretty good. And we're just running out of juice. But anyway, so we have 60. And again, we have 60 divided by 12 divided by 112. So 60 is 5 times 12, which is 10 times 6. And then 12, 112. 12s cancel, and we have positive 5, which we do. All right, so hell yeah, we are almost down to our last one. And we have... and I like this one because it had a perfect amount of fractions dealing with 12ths. So A is going to be 1 plus 2C. C is going to be negative 52 1/12. And then we have minus 3. B is going to be 5 1/12. So, and then this, you know what I mean, boosted up. This is 112 twelfths. And then we have minus 104. Minus 15. So this is going to be, oh, what's that? So if I put a 15, I'm going to do this method. It's going to be 9, 1, this, and then, yes, this sucks. You know, even this, I might use the number line method. I did it before today, but now I can see 2 to 9 is 7. It's going to be negative, negative 7. So that's what we have, and we did it. 9 equations, 9 unknowns. Horrendous. Tons of places for error, but it just shows you like, hey, I could use Gaussian elimination, and it's not that hard because you have all the other ones that are zeros, so you just have these little boxes. You have a lot of the same manipulations that happen, you know, similarly, except it was just those values were in different spots. But I think it's worth a go. Like if you're learning how to do inverse matrices, set yourself up your first 9 equations, 9 unknowns. Because I did just the other day ago. And what I did is I put this one right there, this equation right there, and then this equation right there. And it was just a weird stack. Like the Gaussian elimination just sucked. And it just seemed like everything was all over the place. When you put these little 3 equations together in these little boxes, you can solve them at your leisure. You can get an echelon there, use these to get an echelon there, and use those. And so, hell yeah. So I just thought that was pretty interesting. And I'll do it again. Just because the traditional way is to, and we're just running out of juice, it'll probably, but yeah, the inverse matrix. And we did a part 1 on this, but yeah, the inverse matrix is you have to find the determinant of this matrix, which is some calculation, and then you have to multiply it by the adjoint, which is the the adjoint of A is the cofactor, but it's the transpose of the cofactor. So you still have to do 9 orders of operation to get those numbers, so you have to do 9 things and 9. You have to do 18 things. No, because to get the determinant, you basically have to do like three things. So 3 things plus 9 things, 12 things. You got the inverse. What we did this, we probably did one thing, two things, three things, and then to get the actual operations, 4, 5 things, 5 things per. I think it's close, but this is way tedious. You could say the one thing is a combination always of 3 things. Not if you use your calculator, it's not. We just did a lot of mental math. So it's even interesting with a 3 by 3. It's still, this is like, alright, hell yeah, we juiced out, so we're going to be done. But yeah, this one was just right at the limit that, yeah, this seems doable. This, why I did it this way and showed you this, just because it seems more intuitive. You spend a lot of linear algebra. I mean, if you're going to take any take-homes from linear algebra to do 3 equations, 3 unknowns, it's Gaussian elimination. It's doing row echelon form. That's what this is called. These don't have to be zeros as well. That's row reduced echelon form. Once we get into row echelon form, hey, we at least got one value that's solid. And then the others are just easy manipulations. You know what I mean? I think of that as like, hey, one goes into the other, goes into the other. So row echelon form is hella sweet. And you can watch that prime Newtons on, row reduced echelon form versus row echelon form. And this is one application of it. I love row echelon form. I never do reduced row echelon form, and it's just more places to make errors. Yeah, it's kind of complex. For me, it's definitely complex. But, okay, so we're done with this. I just thought it was cool that you can do 9 equations, 9 unknowns. Now, they definitely say in the book, like, what are you going to do when this matrix is a 10 by 10? And that sucks. And I think it's unruly. Because you would have to do row echelon form for a 10-pack and then 10 10-packs. We did row echelon form for a 3-pack 3 times. So if you had an inverse matrix of a 10-pack, but they were saying for a computer it's like 300,000 calculations if you do a computer. But even a 10 by 10, if you did it by hand, I don't know. I mean, but you can't consider this row echelon form for a 9 by 9 because we have so many missing values it really simplifies. This has to be looked at as a row echelon form for just a 3 by 3. We have 3 by 3 matrix. If you have a 10 stack, if this was 10 numbers by 10 numbers where they're all filled in with numbers, yeah, I think it's going to be, you know, to get this to be zeros, you have to do 9 things. You know, so that's where it gets to be that factorial. To get all those zeros, I'd have to do 9 operations to get those to be zeros. 8, 7, 6, 5, 4, 3, 2, 1, so whatever that is. Yeah, that's brutal. And then once I get that down to 1, I can say it's reduced echelon form, solve up. But I would have 10 of those blocks in 10 locations. So that is crazy. But from setting it up like this, there was no reason I had to set up the grid like this after I know how it's set up. I could have just done 3 smaller grids, and just knowing that they don't overlap. And so even if I did a 10 by 10 matrix, I might take that on as a challenge, just because it's fascinating. And, let's say you spend, I don't know, it would be sweet if I was able to do that in like 2 hours, 3 hours, a 10 by 10 matrix, with the answer already given, because then you could check your errors as you go, and it would just be fascinating, like, how many errors are you going to make? Because that's why I'm doing these videos, is because there's so many places to make little sign errors and multiplication and addition errors. And it's very useful to keep track of where you make those errors. So on the next go around, you can throw up little red flags and be like, hey, let's not try to make those errors. Alright, I'm done. Thanks for joining me, and that's a video.